Okay, number 10 is about Carla. She wants to invest money for her daughter Leela. She puts $63,000, wow, into an account, and it grows at a rate of 2.55% per year, compounded monthly. Now, because I see compounded monthly, it tells me I need to use my compound interest formula. All right, now something I want to underline, because if you miss this, you're going to actually lose a point on this question. It says write a function C of t. Okay, they want you to first write a function. Instead of A, we're going to write C of t. Okay, so they don't want you to just jump right into it. They want you to first write our function. Now we know the initial amount, the P is the initial amount, which is 63,000. And then in parentheses, we're going to have 1 plus the rate. So here it is, 2.55%. To get rid of the percent symbol, we take this decimal and move it twice. So boom, boom. So that's going to be 0.0255. Now, N stands for the number of compounds per year. So if we're compounding monthly, how many months are in a year? 12. So we're going to replace the N with a 12. And we'll have to replace this N out here with a 12 as well. And you want to leave it in terms of T, because they want you to first just write a function C of T in terms of T. So that, I'm going to box that off. That's actually the first part of our answer. Okay, now they want us to use that function, and they want us to calculate algebraically the number of years. So we're looking for the T, how long it will take for the account to reach $100,000. Okay, so we're going to replace this with 100,000. And you could just bring everything else down. All right, so just like, the majority of the problems we're solving in this packet, whenever you're solving for an exponent, we know we need to use logs. But before we do, we need to get the base that contains the exponent on it, so this base that contains this variable exponent on it by itself. So we need to first get rid of the 63,000. So to get rid of that, we could divide both sides by 63,000. All right, I'm going to do the same thing. I'm just going to cross off, I'm going to do this without my calculator, right? Don't these 3 zeros cancel with these 3 zeros, leaving us with 100 over 63. So rather than plugging this in your calculator and writing it on your paper as a rounded decimal, I'm going to leave it as an exact value. And fraction is exact. All right, so those 63,000s cancel out, and I'm going to bring this down. Okay, so now we could put the word log in front of both sides of the equation. So I'm going to bring the left side down, and the reason we put log in front of both sides of the equation is so that this exponent can come to the front, and then it's no longer an exponent. Right? Once it's no longer an exponent, we can solve for it. So I'm just bringing this all down. The only difference between these two steps is I brought the exponent to the front. And if you want, you could do that all in one step. Okay, I'm running out of room, so I'm going to need to move this up. So now I want to get the 12t by itself. So I'm going to divide both sides by log of what's in that parenthesis. All right, so now we're going to have to plug in our calculator. Log of this fraction divided by log of what's in this parenthesis. Okay, and we unfortunately have to round down our paper, but that's okay. We're going to use that entire answer in our calculator. Okay, so this winds up giving us 217.6594. And over here, we're going to bring down the 12t. All right, so all we have to do is divide by 12. And when we do, I'm going to write it over here. T is equal to, now let's look. They wanted us to round to, let me find it, the nearest hundredth of a year. Okay, so in my calculator it says 18.138. So to the nearest hundredth, that would be 18.14. And please do not forget your units, which is years. All right. I always like to box off my final answer or circle it or something to just emphasize it. Okay, number 11. So you may recognize this as Newton's law of cooling or Newton's law of heating formula. Okay, so now as you read, they tell you what everything stands for. It says the Fahrenheit temperature, F of T, so this is our Fahrenheit temperature, of a heated object at time T. So this little t represents the time, and this would represent the Fahrenheit temperature after that time has passed. Okay, it could be modeled by the function below. F, and this little subscript, I think looks like an S, which makes sense. It's the surrounding temperature, maybe S for surrounding. So F sub S is the surrounding temperature, and F sub 0, we usually use this little subscript of a 0 to represent the initial, and that's what it is, the initial temperature of the object. And they tell us that K is a constant. Okay, so when we read the problem, let's see what's what. And I'm going to kind of label as we go. So coffee at a temperature of 195 degrees. So this is the temperature it's at. This is its initial temperature. Now, didn't we say F sub 0 is the initial temperature? So I'm going to label that F sub 0. Is poured into a container. The room temperature is kept at a constant of 68 degrees Fahrenheit. So the room temperature, I would think, would be the F sub S, the temperature of the surroundings, right? The surroundings. So F sub S, let me just go like that, would be 68. Okay. And they tell us K is 0.05. Coffee is safe to drink when its temperature is at most 120 degrees Fahrenheit. So we're probably going to have to figure out how much time it's going to take to reach this temperature. So this is the Fahrenheit temperature after a certain time has passed. So this is going to go in for the F of T. Yep, and look, we're looking for how long? So that means we're looking for the T, the little lowercase t. That's what we don't know. All right, so let's plug all the numbers in. Okay, so I just plugged in all these numbers. Now, I have a mistake up here, and look closely. I purposely made this mistake because I wanted you to, acknowledge it. A lot of people make this mistake, and I don't want you to do it when it comes to, a test or something. Do you guys see it? It's this right here. See how we have a negative? You have to put a negative in front of that. That's built into the formula. Okay, so let's solve. Now, we really solve these the same way every time, right? We first subtract the number that's hanging out by itself from both sides of the equation. So that'll give us, 52 equals. Okay. Now, rather than bring down this whole thing, you might as well just combine these two numbers. So 195 minus 68 would be 127. So we could bring down 127. And then e to that power. All right, so we're trying to get that e by itself, right? That way we can use ln and get rid of it. So let's divide by the number in front of the e. Now I'm gonna just leave this as a fraction, right? Might as well have it as exact as possible. No need to use a decimal in the middle of the problem if you don't have to. So I'm gonna leave that fraction equals e to this power. And now that we have the e by itself, what do? That's right, ln. All right, let me give myself a little more room. So I can bring down the left side of the equation. Oop, that's a 7. Sorry, guys. And we know that when you have ln of e to some power, you're left with whatever that power was. Okay, and if you prefer to do this, you can. All right, now let's just divide both sides by 0.05. Sorry, I just want to fix this. This is there we go. That 7 was kind of a mess. I don't want anyone to have the wrong number. Okay, so I'm dividing by, ooh, look what mistake I made. I forgot about that negative right there. And actually, if I had plugged this in my calculator as divided by positive 0.05, it would give me a negative answer, and I'd have to realize time can't be negative, so I'd have to realize my mistake, but I actually realized it a little sooner. All right, so let's plug this in the calculator and see what we get. Okay, so you're plugging this whole thing in, ln of this fraction divided by negative 0.05. Okay, I did, but what do we have to round to? Oh, right here. Okay, they want us to round to the nearest minute. So basically the nearest whole number. So I got 17.8588, whatever, 67. But that's going to round to 18. So it'll take 18 minutes before it is safe to drink. Number 12, Jim is looking to buy a vacation home for $172,600 near his favorite southern beach. The formula to compute mortgage payment, M, so M represents the mortgage payment. Let me just underline this. So M is the mortgage payment, is this right here, where let's kind of color code things. P is the principal amount, so we know that's the amount borrowed. Okay, R is the monthly interest rate, and N is the number of monthly payments. Okay, so we have 4 variables in there. Okay, so they give us the interest rate right here and a 15-year mortgage, and it says with no down payment. That means he hasn't saved up any money to put down, so he's going to need to borrow the full amount of the price of the house. They want us to determine Jim's mortgage payment to the nearest dollar. So if we're determining the mortgage payment, didn't it say the mortgage payment is M? So M is what we're looking for. All right, so then in place of the P right here, this is the amount borrowed. Well, he has to borrow the entire amount because he doesn't have a down payment. Okay, and then this fraction is R. Now, because there's a percent symbol, we have to move the decimal twice. So it's going to be 0.00305. And then in parentheses, it's 1 plus R. You could write 1 plus, but isn't that just 1.00305, right? If we add 1 plus this decimal, it's just that. So if you want to write the plus sign, you can, but you definitely don't need it. Now, N stands for, right here, the number of monthly payments. So if he's taking out a 15-year mortgage, and there's 12 months per year, we have to figure out what 15 times 12 is. And that's what we're going to plug in for N. Okay, so on the bottom again, we have 1.00305. Right, that's what this is equal to the N power, so to the 180 power, and then minus 1. Okay, so basically, all you're going to do is plug this entire thing in your calculator and see what you get, and you're going to round your answer to the nearest dollar, which means nearest whole number. Okay, so I'm going to take a minute and do that. I'm going to plug it in literally exactly like I see it. I'm going to use alpha y equals to plug in this whole fraction and everything. Okay, so I plugged that whole thing in, and to the nearest dollar, I got $1,247. All right, so that's what his mortgage payment would be if he has no down payment. Now, if we look down here, it says algebraically determine and state the down payment rounded to the nearest dollar that Jim needs in order to make his mortgage payment be $1,100. So instead of his mortgage payment being $1,247, he wants it to be lower. But in order to be lower, he needs to have a down payment. Now, if you remember, right, whenever it asks us to find the down payment, what are we solving for? We're solving for the amount borrowed. We're solving for the P. Okay, so I'm going to go back up. Let me just see that formula. I'm going to go back up to this formula up here. And in place of M, the mortgage payment, he wants it to be right here, $1,100. Let me actually make this smaller so I can see the formula with the question. Okay, so he wants his mortgage payment to be $1,100. And we're solving for the P. Now, none of this is going to change, so you could just copy the same exact thing down in your paper. The interest rate is still the interest rate, and the 15-year mortgage is still the 15-year mortgage. Okay, so in order to solve for P, right, well, first thing we're going to want to do is plug this whole thing into the calculator and write it as a decimal. So I'm going to bring down the 1,100 equals P times, right, whatever this is equal to. All right, I'm going to have to unfortunately round on my paper, but, you know, that happens. And when I plug that in, I get approximately 0.0072. Now, to get the p by itself, we know we're going to have to divide by that decimal, but please do not in your calculator type in 1100 divided by 0.0072. You want to type in 1100 divided by, and then in your calculator, answer, right? So 1100 divided by second negative. Okay, so what I did was after I had plugged in this fraction in my calculator, I didn't do 1100 divided by this rounded value. I did 1100 divided by, and then when we type in second negative, it takes the answer and puts it there. All right, now they want us to round to the nearest dollar. You can round this to the nearest dollar if you want. If I round this to the nearest dollar, I would get P to be $152,193. Now, that's not what they're looking for. P is the amount borrowed. That's what we want to borrow from the bank. So if we want to figure out the down payment, we need to subtract that from the original price of the home. Okay, so let me just scroll back up. Remember, the original price is right here, $172,600. And please show that work, okay? So you're going to do $172,600 minus the amount borrowed, minus the principal amount. And that's what's going to give you the amount, the down payment, okay, the amount you're going to put down. Okay, so I'm getting $20,407. Okay, so the very last question is asking us to write an exponential regression equation. Now, if you remember, we do this right in the calculator. So I'm going to do it, I'm going to show you in the calculator. I'm going to guide you right through the steps. Okay, so to write an exponential regression equation, what we need to do is we need to go to You're going to go to stat. See right here where it says stat? And you're going to click enter on edit. And you're going to plug all of these values into L1 and all of these values into L2. Okay, so I already have them in there. But if you don't, just type them in. And if there's any extra numbers, clear those out. Okay, once you do that, you're going to go back to stat, over to calc, and we're going to, I mean, it's number, you know, it's the 0, but you could scroll down or up, whatever you want, until you see exponential regression. See right there, exponential regression, and you could just hit enter. And as long as this says list 1 and list 2, because that's where we put in our data, you could just go to calculate, and there we have it. So all you're going to do is plug in this value for A and this value for B, and make sure you round to the nearest thousandth. Okay, so again, you're just plugging in 101.523, right, because that 8 rounds it up to a 3 for A. And I like to do, instead of this weird asterisk for multiplication, I like to do a parenthesis, and then you could type in 0.883, and we don't write 2 that way, right? This just means it's an exponent. Okay, now if you look at my equation, what did I do wrong? I plugged in the A, and I plugged in the B. So what's wrong with this? I'll give you a clue. Equation. What am I missing? The y equals. So please do not forget that. Okay, so now part B, or I don't know if they label it B, but use this equation. So use this equation with the rounded values to algebraically determine the altitude to the nearest hundredth of a kilometer when the air pressure is 29 kilopascals. Okay, so they're giving us this number 29. Now, doesn't kilopascals right there, isn't that our y value? So we're going to replace our y with a 29. Okay, and let's just solve. So, I mean, we should be pros at this point, right? We're solving for an exponent, so we are going to use logs. So let's first divide both sides of the equation by that number in front of our parentheses. So 101.523. All right, so I'm going to just leave the left side of the equation as it looks, only because why round if we don't have to? All right, and now that we have, by the way, this right here was just underlying hundredth. That has nothing to do with the exponent. Now that we have the term that contains the exponent on it by itself, now we could put the word log in front of both sides of the equation. And the reason we do that is so that we can bring our exponent to the front. So I'm going to rewrite the left side of the equation. And I'm going to rewrite the right side of the equation, but with the x in front. So now we could see if we want to solve for x, we just have to divide both sides by log of 0.883. All right, so we're going to have to plug this all in our calculator. Okay, so when you plug this in the calculator, make sure you round to the nearest hundredth. All right, so the nearest hundredth, I am getting 10.07, and then look at the top of the page. What are the units that are attached to the x's? Kilometers, right? So 10.07 kilometers. I mean, it says it right there too.